what Lesson 9 is all about, using algebraic expressions, we're introduced to the idea that there are mathematical expressions that have a letter in place of what is a number, making it algebra. That's the key concept, that a letter can represent any number, and we're going to try and find what that number is to make that expression true or correct. In our example problems from the lesson today, all four of those, have you practice solving an algebraic expression by taking the value that they give for that letter. So a equals, for example, 2. You would plug that 2 into the value wherever you have that variable in the expression. If you take a look at our practice problems today, we're continuing that, and I want to show you what those look like so that you can master this skill as we go. For letters A and B, it asks us to simply plug those two values in, and Mr. Shane has done that already to start with. You can see here that here's the expression that we're given, and it says that A equals a certain value and B equals a certain value. I like to take that information that it gives me and write it into the expression right away. Now I'm solving not an algebraic expression, but a numeric expression in which I just simply follow my order of operations. We'll do that in just a minute. In the second example here, letter B, it provides you an algebraic expression because it's got those variables that represent numbers. It gives you the values for what those numbers are, and then you're to solve or simplify that expression. So I've, again, written it from algebraic into numeric expression that I can use my order of operations. In part C here, it's asking you to solve either side, so and then compare. So you're going to do the same thing, substituting for x and y, the values that are listed here inside of the parentheses. And I always like them in parentheses so that they keep the same order of operation or the same symbol of inclusion that the original problem has. And in letter D, it asks you to apply that into a real-world example, which connects us to science class in which you're converting Celsius to Fahrenheit. Let's run through those. The first one, letter A, says 3x minus 4b plus 2bx. Whenever they're next to each other, those letters mean multiplication, so I have written that in the same way. Here, x is value of 10 each time, and b is the value of 2. So we plug those in, and we can do those from left to right or using our order of operations. The first one, 3 times 10, is going to give me 30, minus 4 times 2 is 8, plus 2 times 2 times 10. 2 times 2 is 4, times 10 is 40. And then working from left to right, because those are the exact same operation, addition or subtraction, I would have 30 minus 8, which would be 22 plus 40, gives me 62. In letter B, you've got your algebraic expression. I've already written those values in. Anytime I had an A, I wrote in a -1. Anytime I had a B, I wrote in an 8 and followed the same. Now, order of operations tells us that we can't just use multiplication all the way across, because here we have an exponent. That exponent's value is going to be -1 squared, which is -1 times -1. Two negatives multiplied together would make a +1. So this would be 1 times, in this case, 4. And now I can do my multiplication across the board. So 2 times -1 is -2, times 8 is -16, minus 4 times 1 is going to give me what would be +4 plus 10. -16 minus 4, same sign sum, add them up, would give me -20 plus 10, different subtract, 20 minus 10 is 10. Overall answer is going to be -10. Now, in letters C, it asks you to do a comparison between those values in which you solve one side or the other. Order of operations is just going to simply ask us to solve or separate those two and then use order of operations in that specific, or symbols of inclusion in that specific problem. So here we've got exponents and set of parentheses. Let's start with what we need to do first. Just looking at this from left to right, I'm going to do my exponents first. So I have 2 times 2 is 4, times 6 is going to give me 24. 5 to the third power here is going to give 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Minus, in this section, 2 to the 6th power. What is 2 times 2? 2 times 2 is 4. I'm just going to count on my hand how many of those 2's I've used. Times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Here I have 64 times 3. 64 times 3 is going to give me 192. And now I can calculate on that left-hand side with my addition and subtraction. Well, let's go over here to use these exponents first. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 8, I can write that on the side or use a calculator. 8 times 6 is 48, carry the 4. 8 and 1 is 8 plus 4 is 12. So that's 128 minus 5 times 5 is 125. This answer over here is going to be 3. I've got 24 plus 125, which is going to give me 149 minus 192. 192 minus 149 as a subtraction problem is going to give me negative 43. My alligator is going to eat the large number because this number is negative. In the last problem, it asks you to apply this using our conversion. It says the lowest recorded temperature is negative 89.4 degrees Celsius in Antarctica. The expression 9/5 times Celsius plus 32 converts that into your Fahrenheit temperature. What is the lowest recorded temperature in degrees Fahrenheit? So you see that Mr. Shane has already taken that Celsius degree temperature that it's given us, plug that into the algebraic expression to make it a numeric expression. Now I follow my order of operations. I take negative 89.4 and I multiply by 9, and then I would divide by 5, separate those two, multiply by 9, divide by 5, and then add 32. Because it's negative, this answer is going to be negative, and then I'm adding 32 to give an overall value of negative 128.92 degrees Fahrenheit. You can check that with a calculator. Find out that that's how you would do that conversion by plugging in the Celsius degree and then following order of operations. Again, lesson 9, take that algebraic expression, plug in the value that it gives you, and then solve using symbols of inclusion or order of operations to do it correctly. Hope that helps.